What are other forces acting? mg. So then this will have some velocity, say v1 dash. Because of tension acting towards right, you take the horizontal component of tension is there. In what direction that horizontal component will act? T sine theta will act towards right. So what do you expect the trolley? Trolley will acquire a velocity v2 dash. So because of this tension now, so T sine theta, the trolley will be moving towards right here. Now, what is the state of Bob? What will happen to Bob? What will happen to Bob gradually? A component of m1g sine theta, or say m1g sine theta will act opposite to velocity. So the speed of the Bob keeps on decreases. Agree this? And the speed of the trolley keeps on increases. So at one instant, what will happen? Both this will have common velocity in ground frame. There's a maximum theta or theta m, you write it. Or with respect to trolley, the bob will be at rest. With respect to trolley, the bob will be at rest. In the ground frame, both will have common velocity. So with respect to trolley, when bob comes to rest, then only the deflection will be maximum. No, it's asking that maximum deflection of the string. How to calculate this? Okay, let's look at what is the net force acting on system along x-axis. 0. Net force acting on system along x-axis is 0. So can we conserve momentum? Yes, we can conserve momentum. How weight are acting? So the normal contact here, N1, take in this one. So the weight of the trolley, M2G, somewhere you can show it. So what are the only forces that are acting along x-axis? Tension, and the net force on system along x-axis 0, no? So what do we expect now? The momentum should be conserved. So I'll apply conservation of linear momentum. So applying conservation of linear momentum, sigma fx0. So initial momentum m1u should be equal to m1v plus m2v. So there's a one equation one you keep in mind. We wanted that theta m, no? How to bring that one? Can we apply conservation of mechanical energy? Tension does positive work on the trolley. What about the weight m1g? It does negative work. What about the tension on the bob? Will it does any work? Yes, it does work. Component of tension will act along x-axis, no? And component of tension. So net work done by tension here, in fact, will be 0 on the system. So what is the only force doing work? It is the weight of the bob. So therefore, conservation of mechanical energy, initial kinetic energy of system, m1u square should be equal to m1v square by 2, m2v square by 2 plus increase in gravitational potential energy. To what height it has raised? Initially the bob is here, no? So it has ascended an height h. So shall we write it as equal to m1gh? How to get h? I think by this time everyone knows h will be L into L minus cos theta m. So putting this m1u square by 2, m1v square by 2, m2v square by 2 plus m1g L 1 minus cos theta m. This equation 1, solve for v, substitute here, then we'll get expression for theta. I'll just give all the description ideas later on if you want to work out. Okay, this is about the maximum angular displacement. After this, you see one more thing is asking. What is it? Maximum speed of the trolley during subsequent motion. What will happen to the bob here? Will it be there only? So it will start swinging, no? So as it starts swinging, like this, as it further starts swinging, how the tension will be acting on the trolley? It will be still towards right. So what will happen to trolley? Trolley will accelerate, no? So the velocity of trolley will further increase. Then the next situation will get a I'll take it out that. Now, so this is what happens here. No? So this theta m, I'll take it out. Now, so at one instant, the velocity of trolley will be maximum. So why do it will happen? Because look at the diagram. The component of tension will be acting towards right. So again, with respect to trolley, the bob will be at rest here. Because of component of tension acting, the trolley will further accelerate, speed will increase. Then here, with respect to, now what happened? With respect to ground, it is having velocity v. Or with respect to trolley, it will be at rest. No? After this, what happened? It starts swinging back. It starts swinging back, that one. Then when the string becomes again vertical, the bob will be moving with a velocity v1 and the trolley will have maximum velocity. Now the speed of the trolley will be maximum. On what basis we can put this condition like this? Very next moment you take it. Very next moment again. If you are able to imagine, well and good, no need of diagram. I'm making things clear. If you are able to imagine, there's no necessity of diagrams. Straight away you can write equation. If you are unable to imagine, then you have to draw diagram. So when the string makes an angle, so this is the, take some theta or theta 3 something. So let the velocity of this v3, v2, let this be v4. v3, let this be v4. And now how the tension will act, you check it. T3, T3. The component of tension will act opposite to velocity of trolley. So here with all this diagram, so the speed of the trolley is maximum when again the string becomes vertical. No? So if you check it now, the component, the moment the bob starts swinging towards left from this position, the tension what happened will act opposite to the trolley. So the speed of the trolley now start decreasing. So among all this is the maximum. Speed of the trolley here is maximum. So therefore I'm writing V2M. So here the maximum speed. This maximum speed, it has to be determined. And what is the conclusion? V4 less than V2M. And V2M and V is less than V2M. So therefore the maximum speed of the trolley is 0. How to determine that? You can apply between the second and third diagram. So we have all the sequences. This is the first diagram, second diagram, third diagram, fourth diagram, fifth diagram. So you look at the total situation. We have to calculate maximum speed. Can I apply conservation of momentum between first and fourth, or I should apply always in order? No, you can apply between 2 and 3 and 4. You can apply between 1 and 4. Anything, it's left to you. So directly I'll apply between 1 and 2. So from diagram, figure 194. What is the initial momentum given? M1u. Final momentum, M2 V2M minus M1 V1. Two things unknown, no? V2M as well as V1. I'll apply conservation of mechanical energy. M1 u square by 2 equal to m2 v2m whole square by 2 plus m1 v1 square by 2. Why there is no potential? Look at the bob. What was the initial position? It is at same horizontal position. So therefore, what do you expect the change in potential will be 0. Solving this, we'll get the required answer. So we have to analyze the situation here. It's not that we have to analyze situation. So we don't have any formula, like don't expect any formula like one formula will come, I'll substitute. Come for this now. A stationary body of mass m exports into 4 identical fragments in free space. 3 are